Thank you for listening. This course was created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional podcasts, books, newsletters, and cool merchandise await. Let's get started. Hallucinations in large language models refer to situations where a system produces outputs that sound confident but are factually false or misleading. This problem has become a central focus for both researchers and governance bodies because it undermines reliability in ways that can have real-world consequences. Unlike simple mistakes, hallucinations are particularly concerning because they are often delivered with high fluency and apparent authority, making them difficult for users to detect. In domains such as healthcare, finance, or law, even a small error can result in significant harm. The framing of hallucinations as a systemic issue reflects the growing recognition that factuality is not a secondary concern, but a defining characteristic of responsible artificial intelligence. Addressing hallucinations means aligning outputs with truth, and without this alignment, AI cannot be trusted in high-stakes or widely deployed contexts. Hallucinations occur for several interrelated reasons, all of which connect to the underlying mechanics of large language models. At their core, these systems predict patterns of language rather than verifying facts against external reality. They are trained on noisy datasets that inevitably contain inaccuracies, outdated information, or biased representations. Because models generate probability-driven outputs without an embedded truth filter, they can fabricate information while still producing text that seems plausible. The lack of grounding in external knowledge bases or real-world references further compounds the problem. This probabilistic approach makes them powerful for creativity and fluency, but unreliable when factual precision is required. Understanding why hallucinations occur sets the stage for developing both technical and governance-oriented strategies to address them. Different types of hallucinations manifest in distinct ways, each posing unique risks. Some involve fabricated facts, such as non-existent laws, imaginary citations, or invented statistics. Others stem from misinterpretation of instructions, where the system generates text that diverges from what the user intended. Overgeneralization can occur when the model extrapolates beyond its training data, presenting assumptions as facts. Contradictions within the generated text, where an output contains internally inconsistent claims, further highlight the system's lack of grounding in truth. Each of these types illustrates that hallucinations are not anomalies, but predictable outcomes of how models process information. By categorizing hallucinations, practitioners can better tailor evaluations and mitigations, distinguishing between errors of fabrication, misunderstanding, overreach, and inconsistency. The consequences of hallucinations extend beyond technical shortcomings, with implications for individuals, organizations, and society. Misinformation spread by AI can travel quickly, especially when embedded in persuasive or authoritative-sounding outputs. User trust erodes when audiences realize that systems cannot be relied upon for accuracy, diminishing the value of AI deployments. Legal and regulatory risks emerge if false outputs cause tangible harm or violate standards of truthfulness. Vulnerable populations are particularly at risk, as they may rely on AI for critical information in areas like health or education without the expertise to fact-check results. These consequences demonstrate that hallucinations are not trivial mistakes. They are systemic risks that require structured interventions to prevent harm and maintain confidence in AI technologies. Factuality, by contrast, represents the aspiration to align outputs with verifiable truth. Achieving factuality requires models to rely on trusted data sources, grounding responses in evidence rather than generating plausible but unsupported text. Metrics for factuality emphasize the degree to which outputs match external knowledge, whether through alignment with databases, citation of sources, or validation against benchmarks. In regulated or high-stakes domains, factuality is a compliance necessity, shaping whether AI is adopted at all. Organizations that prioritize factuality not only reduce risk, but also enhance trust, creating a foundation for broader integration of AI systems. Viewing factuality as both a technical and governance goal reframes it from an optional improvement to an essential requirement of responsible deployment. Evaluating hallucinations requires systematic metrics that move beyond anecdotal observations. Research has developed truthfulness benchmarks, where models are tested against carefully curated sets of questions with known correct answers. Manual fact-checking of sample outputs remains valuable, particularly for identifying subtle or context-specific inaccuracies. Automated alignment with structured knowledge bases provides scalable ways to verify outputs, though these methods have their own limitations in coverage and currency. User reporting of inaccuracies adds another feedback channel, ensuring that evaluation reflects real-world use. By combining manual, automated, and user-driven metrics, organizations can develop a multi-layered view of factuality performance. This diversity of approaches acknowledges that no single metric is sufficient, but together they provide actionable insights for continuous improvement. Mitigation strategies for hallucinations focus on aligning model outputs more closely with verifiable information. One prominent technique is retrieval-augmented generation, where models are connected to external data sources and must ground their responses in retrieved evidence rather than inventing content. Fine-tuning with curated, fact-based corpora helps reduce exposure to noisy or unreliable patterns in training data, creating a baseline of higher factual accuracy. Constraints in decoding, such as requiring outputs to follow structured formats or limiting certain speculative language, further reduce the likelihood of unsupported claims. Continuous monitoring of outputs ensures that hallucinations are detected and addressed as systems evolve. These strategies illustrate that hallucination mitigation is not a single fix, but an ongoing blend of architectural, training, and operational approaches. Their effectiveness depends on combining technical interventions with oversight and governance. Knowledge bases play a pivotal role in improving factuality, offering structured external grounding that models can reference. Unlike unstructured text, knowledge bases provide curated, validated data that can serve as authoritative anchors. By integrating them into AI systems, developers enable automatic fact-checking and the transparent sourcing of answers. This is particularly useful in domains like healthcare or law, where verifiable references are essential. Knowledge bases also support traceability. When a system cites a source, users can evaluate the credibility of the information for themselves. However, reliance on knowledge bases introduces its own challenges, such as maintaining freshness, addressing gaps in coverage, and managing biases present in the source material. Despite these complexities, the role of structured data is indispensable in reducing hallucinations and enhancing trust. Human oversight remains a vital safeguard, particularly in sensitive or high-risk applications. Automated systems, however sophisticated, cannot fully account for the nuances of truth, context, and interpretation. Human reviewers can assess outputs in cases where stakes are high, such as medical guidance, financial recommendations, or legal information. Escalation processes ensure that disputed or uncertain outputs are examined carefully before being released. In regulated sectors, oversight panels or committees may be established to provide governance-level review. Feedback from human oversight loops back into training and monitoring, helping systems improve over time. While this adds cost and latency, it provides assurance that machine outputs are not treated as unquestionable authority. Human oversight anchors AI systems within broader accountability structures, ensuring that factuality is checked through judgment as well as computation. Trade-offs inevitably arise when mitigating hallucinations. Imposing strict constraints can limit the creativity and flexibility that make generative models appealing. Retrieval-augmented generation, while improving factual grounding, introduces additional latency as systems must query external sources before producing outputs. Human oversight improves reliability but increases costs and may slow response times, making it difficult to scale. Balancing these competing factors requires context-sensitive decisions. Creative applications such as storytelling may tolerate higher hallucination rates, while healthcare systems must prioritize factual accuracy at the expense of speed. Recognizing and managing these trade-offs ensures that mitigation strategies are tailored to the needs of specific use cases rather than applied as one-size-fits-all solutions. Organizational policies formalize how hallucination risks are managed. Guidelines can define acceptable thresholds for error rates depending on application domains, acknowledging that some hallucinations may be tolerable while others are not. Documentation of mitigation techniques ensures transparency, helping stakeholders understand how factuality is being pursued. Disclosure to users, such as warnings about potential inaccuracies, builds honesty into system deployment. Training staff to recognize and respond to hallucination risks prepares organizations for the realities of operating imperfect systems. Policies align operational practices with governance commitments, embedding hallucination management into broader risk frameworks. Without explicit policies, hallucination mitigation remains ad hoc, undermining consistency and accountability. Ethical implications are inseparable from discussions of hallucinations and factuality. Organizations deploying AI have a responsibility to prevent harm caused by misleading or false outputs. Respect for user autonomy requires that information provided is accurate enough to support informed decisions rather than manipulation. False content risks not only individual harm but also broader societal consequences, such as undermining trust in institutions or fueling misinformation. Accountability structures, both internal and external, must be established to ensure that systems are not simply producing plausible text but verifiable truth. Ethical reflection reframes hallucination mitigation not as an optional enhancement but as a duty of care. This perspective elevates factuality to a moral imperative, connecting technical safeguards to the broader responsibilities of organizations and their AI deployments. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Regulatory pressures are rapidly reshaping how organizations approach hallucinations and factuality. Policymakers recognize that inaccurate outputs can cause material harm, particularly in high-risk domains like healthcare, finance, and education. As a result, calls for mandatory factuality standards are growing louder. Legal liability frameworks are beginning to emerge, where organizations may be held responsible for damages caused by harmful misinformation produced by their systems. Standards for accuracy metrics are under development, aiming to provide clear benchmarks for compliance and evaluation. Anticipated AI-specific legislation in regions such as the European Union is likely to include factuality as a formal requirement for system certification. These pressures transform hallucination management from a best practice into a regulatory obligation, requiring organizations to demonstrate not only that systems function, but that they produce outputs aligned with truth. Continuous monitoring provides a practical pathway for managing hallucinations over time. Real-time detection tools can flag likely false outputs, allowing them to be intercepted before reaching users. Alerts for high-risk hallucinations, such as those involving medical or legal claims, ensure that issues receive immediate attention. Dashboards provide oversight teams with visibility into trends, such as whether hallucination frequency is increasing or decreasing under certain conditions. Monitoring also supports iterative updates, as findings can inform retraining, reconfiguration, or the addition of new safeguards. This approach ensures that hallucination management is not static, but adaptive, keeping pace with both adversarial challenges and shifting expectations. Continuous monitoring reinforces resilience by embedding vigilance into the everyday operation of AI systems. Cross-disciplinary contributions are vital for tackling hallucinations effectively. Linguists contribute expertise in analyzing language errors, helping to distinguish between stylistic variation and factual inaccuracies. Knowledge engineers design and maintain reliable databases that provide grounding for retrieval-augmented systems. Governance experts establish oversight policies and accountability structures, ensuring that factuality aligns with organizational commitments and external regulations. End users also play a role by reporting failures and providing real-world feedback, ensuring that monitoring reflects lived experience rather than abstract metrics alone. By combining insights from multiple disciplines, organizations develop more comprehensive approaches to hallucination management, bridging the gap between technical fixes and social realities. Collaboration across fields ensures that solutions are robust, contextually aware, and ethically grounded. Transparency serves as both a safeguard and a trust-building mechanism in addressing hallucinations. Disclosing limitations openly helps users understand that AI systems are probabilistic and may produce inaccuracies. Providing citations for outputs enhances credibility, allowing users to verify claims for themselves. Maintaining clear distinctions between fact and inference prevents models from blurring the line between evidence and speculation. Encouraging users to interpret outputs responsibly further empowers them to recognize and challenge potential errors. Transparency does not eliminate hallucinations, but it helps mitigate their impact by ensuring that users are informed participants rather than passive recipients. By embracing openness, organizations transform factuality from a hidden vulnerability into a shared responsibility between developers, operators, and users. Training innovations are advancing the ability of models to manage hallucinations more effectively. Reinforcement learning approaches incorporate factual grounding as part of the reward signal, incentivizing models to prioritize truthfulness in their outputs. Integration of human feedback ensures that truth is not narrowly defined by probability distributions, but by expert verification and user expectations. Synthetic datasets designed for fact-checking expose models to a wider variety of factual challenges, strengthening their resilience. While these innovations show promise, they are still evolving, and scaling them across domains remains complex. Nonetheless, they highlight the trajectory of research, moving from fluency-first design towards systems where accuracy and reliability are treated as primary performance metrics. Training innovations signal progress toward embedding factuality into the core architecture of AI. Organizational responsibilities anchor hallucination management in operational practice. Resources must be allocated to fact-monitoring teams that oversee outputs and identify risks. Reporting protocols ensure that hallucinations are systematically documented and escalated when necessary. These responsibilities extend into alignment with broader communication and trust policies, ensuring consistency across the organization's interactions with users and regulators. Integration with AI management systems embeds hallucination mitigation within governance frameworks, tying it to risk registers, audits, and accountability chains. By treating hallucination management as an organizational duty rather than a technical add-on, companies demonstrate their commitment to building systems that serve users responsibly. This commitment ensures that factuality is upheld not just in code, but in culture. Future research into hallucinations and factuality is advancing in multiple promising directions. Improved benchmarks are being developed to evaluate truthfulness more systematically, moving beyond small test sets toward diverse and dynamic challenges that mirror real-world use. Researchers are also exploring symbolic reasoning methods, integrating structured logic alongside probabilistic modeling to improve grounding. Hybrid systems that combine statistical learning with formal reasoning offer potential breakthroughs, especially for domains requiring precise factual alignment. Advances in interpretability are another area of focus, aiming to explain why hallucinations occur and how they might be prevented. By shedding light on internal mechanisms, interpretability supports both debugging and accountability. Collectively, these research directions illustrate that hallucinations are not simply a byproduct of scale but an active frontier for innovation and governance in AI development. Practical takeaways remind us that hallucinations are systemic to large language models rather than occasional glitches. Mitigation requires both technical and governance strategies, blending methods like retrieval-augmented generation and curated fine-tuning with oversight policies and user transparency. Continuous monitoring is essential, as risks evolve alongside data, usage patterns, and adversarial creativity. Transparency builds trust, particularly when users are given clear signals about potential inaccuracies and pathways to verification. These lessons highlight that addressing hallucinations is not a matter of eliminating them entirely, an unrealistic goal, but of managing them effectively, reducing their frequency and impact, and ensuring accountability when they occur. For practitioners, the takeaway is to view factuality as a discipline that requires vigilance and iteration, not a one-time solution. The forward outlook suggests that hallucination management will become increasingly central to regulatory frameworks and industry best practices. Stronger requirements for accuracy are expected, especially in high-risk applications where errors can cause significant harm. Retrieval-augmented generation is likely to see broader adoption as organizations seek reliable grounding mechanisms. Transparency of sources through citations, references, or metadata will become a standard expectation, both for compliance and for user trust. Multimodal systems will expand the scope of factuality challenges, requiring tools that validate truth across text, images, and audio together. As AI continues to integrate into critical infrastructure, the pressure to demonstrate factual reliability will intensify, making hallucination management a cornerstone of responsible deployment. A summary of key points reinforces the central lessons of this episode. Hallucinations arise because large models predict patterns without grounding in truth, leading to fabricated facts, misinterpretations, and contradictions. Their consequences include misinformation, erosion of trust, and legal or regulatory risks. Mitigation strategies range from retrieval and fine-tuning to constraints and monitoring, supported by knowledge bases and human oversight. Trade-offs such as latency, cost, and reduced creativity must be managed thoughtfully. Organizational policies, ethical reflection, and regulatory pressures ensure that hallucinations are addressed not only technically but also socially and legally. Together, these points establish hallucination management as both a technical challenge and a governance imperative. In conclusion, hallucinations and factuality represent a defining issue for modern AI systems, shaping whether they can be trusted in sensitive or large-scale deployments. Addressing the causes of hallucinations requires integrating technical mitigations with policies, oversight, and transparency practices. Factuality is not optional. It is essential for ensuring responsible AI that protects users, complies with regulations, and sustains trust. Organizations that take ownership of this challenge position themselves as credible and ethical leaders in AI deployment. As we move forward, the focus turns to evaluation design, where structured testing frameworks will help quantify and manage factuality risks more effectively. By pairing research innovation with governance discipline, the field can advance toward AI systems that are both powerful and reliable. Thanks for tuning in to Bare Metal Cyber, your trusted source for cybersecurity educational materials, news, and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.